In this video, I'll be discussing how to solve number 6, 8, 9, 10, and 11 of Dimensional Analysis Practice Worksheet. Let's start with number 6. In this case, I am going from millimeters to nanometers. Recall that anytime I move from milli to micro, it's by times 3 zeros, and from micro to nano is also by 3, and from nano to pico is also by 3 zeros. In other words, I am telling you that in 1 millimeter, there are 1,000 micrometers, and in 1 micrometer, there are 1,000 nanometers. So you combine the two and you get 1 millimeter is equal to 1 times 10 to the 6 nanometers. You start with what you know. I know that there are 4.5 millimeters. I want to end up in nanometers. So in between goes my conversion rate. Here's my conversion rate. So you tell yourself which one makes sense. I want to put millimeters at the bottom here so they cancel out. So 1 millimeter is equal to 1 times 10 to the 6 nanometers. Don't forget to cancel out your units. And your answer becomes, you just multiply straight across, 4.5 times 10 to the 6 nanometer. And that's your answer. Number 8. I am going from milliliters to liters, which is the base. So anything to the left of micro, we just move by 1 decimal point or by 10. So I say the conversion rate would be 1 liter is equal to 1,000 milliliters. Or I can say that 1 milliliter then is equal to 1 times 10 to the negative third liters. So I start with what I know. I have 60 milliliters. I want to end up in liters, so put that over 1. So I look to see which conversion rate I want to use. I can either use this or I can use this, but to make my life simple, I'm actually going to use this one because then that means I can just multiply straight across. So liters go at the top, milliliters go at the bottom, cancel out my units, crisscross cancel out, then I can multiply this straight across. So my answer becomes 60 times 10 to the negative third liters. But you got to make sure that you put this in the right scientific notation, right? Because at this point, 60 times 10 to the third is not a right scientific notation. So I am going to revise this and say it's 6, so just one whole number in the ones place, 0.000 times 10 to the negative third. I need to make sure I have 4 significant figures, 1, 2, 3, 4 in my answer, because that's what I started out with. I started out 1, 2, 3, 4, 1, 2, 3, 4 in my original question. So my answer has to be in 4. Number 9 wants to know what is the average weight in grams if the total weighs 4,400 pounds per 40 students. So let's investigate that. One thing I forgot to give you guys is that 2.2 pounds is equal to 1 kilogram. So let's write that. 2.2 pounds is equal to 1 kilogram. Now that we know that, let's start with what we know. If it was any other original problem, you would know that in order to find average weight, you would just divide 4,400 pounds divided by 40 students, right? So that would be your first step. So 4,400 pounds over 40 students. You also know the unit you're going to end up with, which is in grams. So if I just go 4,400 pounds over 40 students, it would give me my answer in pounds, right? And I don't want it in pounds. So let's say that 2.2 pounds is equal to 1 kilogram. So I can go ahead and cancel out pounds, and I'm left with kilograms. I still have a problem because I don't want my answer in kilograms. I want it in grams. So I'm going to fix that. So I'm going to say, okay, 1 kilogram then, which can cancel, is equal to 1,000 grams. And now I can go ahead and solve. I'm going to multiply everything at the top straight across. I'm going to multiply everything at the bottom straight across. So let's start with the top. I can rewrite that as 4.4 times 10 to the third pounds times by 1 kilogram times by 1 times 10 to the third grams. And my answer is 4.4 times 10 to the 6th at the top. On the bottom, I have 40, which can be 4 times 10 to the first power, times by 2.2, times by 1 kilogram, times by 1 student. My answer then becomes 8.8 times 10 to the first power. Now I just have to divide the two. So divide this one by this one. When I do that, 4.4 times 10 to the 6th divided by 8.8 times 10 to the first, I automatically notice that 4.4 is half of 8.8, right? A half. So in other words, 0.5. And the next step is to just combine your exponents. So 6 minus 1, so I get 0.5 times 10 to the 5th power. But that's not the right way to write my scientific notation, right? So I need to fix that. So move that decimal over. So I get 5 times 10 to the 4th. So I plug this guy back up here, and my answer is going to read 5 times 10 to the 4th grams per student, which is to say 50 kilograms per student. This question is a density problem. You're given the mass and you're given the density and you have to find volume. So automatically in your mind you know that if I have to find volume, then I have to do mass divided by density. So let's start there. You're going to say, okay, mass, which is 20.0 grams over 1, and somehow divided by my density, right? I see that my density is 4.0 grams over 1 milliliter. As it stands right now, I can't plug this in to my dimension analysis problem because my grams is at the top and my grams is also at the top at this point, and they won't cancel out, so I can't use that. So let's think. Recall that in the beginning of our dimension analysis lesson, I made you guys write option A and option B for all the conversion factors. And you wrote that if one liter is equal to 1,000 milliliters, then at the same rate, I can write that 1,000 milliliters at the top is equal to 1 liter. Remember we learned about that? So in this case, all you have to do is take your density and put it in terms of A and B. So we're going to call 4.0 grams over 1 milliliter as A. Okay, then B would be 1 milliliter at the top over 4 grams. So A and B is the same in terms of value, but one I write grams at the top and the other one I write grams at the bottom. Now I can plug this in over here. So let's do that. So I say 1 milliliter, which is my density, over 4.0 grams. Nice. Now my grams can cancel out. I know that my answer has to be in liters, right? So I look and I say, oh no, at this point my answer is going to be in milliliters. So I need to change that. So I'm going to say milliliter at the bottom. So I could write 1,000 milliliter is equal to 1 liter. I could do that. Or right now, just to make my life a little bit easier, I'm going to write that 1 milliliter is equal to 1 times 10 to the negative third liter. Now we just have to solve straight across at the top, and then I'll get is 20.0 times 10 to the negative third at the top, and just 4.0 at the bottom, which gives me 20 divided by 4, 5, keep this, so times 10 to the negative third. But you have to keep in mind that we're dealing with significant figures, and I see that I have 1, 2, 3 sig figs at the top, and I have 1, 2 at the bottom. So the least number of significant figures at this case is 2, so I have to make my answer in 2 sig figs. So my answer is going to be 5.0 times 10 to the negative third liters is my volume. The last question was same as number 10, except the mass given to us is 20 nanograms, and it wants to know the volume in liters. So it's the same thing. I have my mass here, 20.0 nanograms over 1, and my density still stays the same. It's 4.0 grams per milliliter. And at this point, just yet, I can't cross out nanograms and grams. So I have to first change nanograms into grams. That's my main goal. So I can say that in 1 nanograms, there are 1 times 10 to the negative 9 grams. Or in other words, I am saying to you that in 1 gram, there are 1 times 10 to the 9th nanograms, right? And then the next step would be to cross out my nanograms. I am left with grams, so I'm good to go there. So I am going to then divide it by density, divide my mass by density to get my volume. So my density again is 4.0 grams per milliliter, but I can't have grams at the top and grams at the top to cancel out, so I have to flip this over. So 4.0 grams over 1 milliliter. So grams and grams cancel out. But I don't want my answer in milliliters. I want it in liters. So again, I have 1 milliliter. And then I'm going to put the 1 milliliter is equal to 1 times 10 to the negative third liters, right? Now all I have to do is multiply straight across. At the top, I get 20.0 times 1 times 10 to the negative 9, so times 10 to the negative 9. Then multiply that by this. So I just add this here. So really it's not negative 9, but it is going to be negative 12. Negative 12. Divided by, at the bottom, 1 times 1 is 1, 1 times 4 is 4, 4 times 1 is 4, so it's 4.0 at the bottom. 20.0 divided by 4.0 would give me 5, so 20 divided by 4 gives me 5. The least number of sig figs is 2, so 5.0 times 10 to the negative 12 liters. And that is my answer. Please study. And if you have any questions, come to my study session at 7:45 tomorrow, okay? Happy studying, everyone. See you Monday.